Another way of classification that most of you would be aware of is that of odd and even numbers. So numbers could be odd or they could be even. And it's pretty known, easy, everyone knows. So 1 is an odd number, 2 is an even number, 3 is an odd number, 4 is an even, 5 odd, 6 even, 7 odd, 8 even, and so on. Right? So we see that 2, 4, 6, 8, 10, 12 and so on are even numbers which are multiples of 2 as we know, and these are odd numbers 1, 3, 5, 7, 9, 11. If you know 2 ones are 2, 2 twos are 4, 2 threes are 6. So if I say this is the first even number, so that becomes 2 ones are 2. The second even number, 2 twos are 4. The third even number, 2 threes are 6. 2 fours are 8 and so on. So the 50th even number is 2 into 50, 100. And the odd number, the corresponding odd number is 1 less than it. So the 50th odd number will be 100 minus 1. 100 is 2 into 50, right? So in a general case, the nth even number is 2n and the nth odd number is 2n minus 1, right? Now, I've been saying all this very loosely when we are talking about natural numbers only. So when I say the first even number, I refer to the first natural even number. What I'm trying to tell you here is that the concept of odd and even, while predominantly is understood for natural numbers, can be extended for integers also. No known relation, theory or so on related to even odd numbers goes into disarray or becomes wrong just because this idea is extended to integers. So let's go back. 4, 3, 2, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5. These also could have been considered as even and odd integers. Though, as I said, we are not going to be mathematicians. We are not dealing purely in number theory. We are preparing for an aptitude exam. However, this also clears a lot of people have this confusion: is 0 an even number? Yes, 0 is an even number. Having said that, a lot of our applications are only about natural numbers, so 0 being even doesn't arise in that particular case because it's not a natural number. Anyway, don't waste too much time out over that. All I would say is even numbers are represented in general as 2n. Odd numbers could be 2n minus 1 or the next one will be 2n plus 1. You could take any of the representation for odd numbers, right? Depending upon which one would serve your purpose better. Yeah. Very little difference. When it comes, we'll have a look at it that way. So that's about it. And surprisingly, CAT has quite a few questions on even and odd numbers, right? So we'll have a look at what are those questions based on. The questions are mostly based on, if I add, subtract two odd even numbers, what is the result going to be? So let's start with, if I have an even number plus or minus an even number, what is it going to be? Or for that matter, if I have an odd number plus or minus an odd number, what is that number going to be? So questions like this, right? How I will think about is, I will think is there, when we are doing addition, subtraction, is there an extra one present? By that extra, I mean compared to a multiple of 2. Even number is a multiple of 2, a complete multiple. There's no extra one. Remember that 2n plus 1. 2n plus 1 was an odd number, a multiple of 2, and that extra one, right? That is what I mean by that extra one. So in an even number, there's no extra one. In an even, there's no extra one. If there's no extra one, it is going to be an even number. So even plus even is even. Odd plus or minus odd is odd. Wrong. That's not the way you think. You think, oh, this has an extra one. this has an extra 1, either the ones will cancel out or they'll add up and become a multiple of 2. So eventually when you do, they will cancel out and there's no extra 1 left for me. So this will also be an even number, right? And what if I have an odd number plus an even number? Or the even doesn't have an extra 1, this has an extra 1. If we add, that 1 will remain. If we subtract, that 1 would still remain. So I would have the result as an odd 1. I hope you understand that part, right? Why that is? Because I don't want you to mug this up, because there can be many such relations. What if I have 3 even numbers, even plus even plus even? Oh, there's no extra 1, nothing, nothing. So the answer is going to be even for that matter. Summation of any number of even, however many even terms there may be, doesn't matter, it's going to be even. But then, if you look at the case of odd, 3 odd numbers, odd plus odd plus odd, or even a subtraction, that could be, right? And 1 and a 1 will cancel out because it will become a multiple of 2. There's an extra 1 left. So now the answer is odd. Sum of 2 odd numbers is even. Sum of 3 odd numbers is odd. What if I have 4 odd numbers? Odd, odd, and another plus or a minus odd, and another plus or a minus odd. Oh, the 1 and a 1, oh, they will cancel each other. 1 and a 1, they'll also cancel. So there's nothing left, that will be an even number. I hope you get it, right? What if I have out over here? So I'll just write it in a little short notation. If I have an odd, even, even. Oh, there's a 1, there's nothing, that 1 remains till the end. So my answer is going to be odd. What if I had an odd, and an even? 1 and a 1, there's nothing here. Oh, the 1 and 1 will cancel and I will have an even number. Hope you get the idea, right? So this is about addition, subtraction. When we come to multiplication, I'll think differently. I'll start thinking of, can it, the product order, can the multiplicand, the product, can it be divided by 2? This is how I will think. So, for example, the moment I have an even number into anything, whatever this may be, whether it's even or doesn't, can I divide it by 2? Oh, an even number is of the form 2n, so the 2 will cancel out. So it can be divisible by 2, so the answer is going to be even. So the moment I see an even into, I know the answer is even, I don't even have to look ahead. However, if I had an odd number multiplied with an odd number, when I try to divide this by 2, that 2 cannot cancel either of them. So that 2 will remain in the denominator, right? It's not going to, but we are not going to be completely divisible. And if a number is not completely divisible by 2, it is odd. So odd into odd is odd. For that matter, if I had another odd number, it is still going to be odd, and so on, right? So I hope you get any product of odd numbers will always remain odd. And you should be able to use this in the reverse sense also. So if I say A into B into C into D, let's say, is odd, the conclusion is each of A, B, C, D, each of A, B, C and D is odd. Had there been even a single even number, I would have something of the type even into, and then my answer would not have been odd. I hope you understand this, right? And just because I write to make you appreciate the difference between that, if I had A into B into C into D is even, I cannot say each is even. One number is enough to make it even. So my only conclusion is at least one of A, B, C, D is even, right? All may be even, it is possible, then also the product will be even, but I don't know what is happening. So all I can say is just at least one. And I'm ending this with a power relation. A power relation is nothing but multiplying by itself, right? So even number raised to anything, I don't even want to think about it, what is it, right? Number even into anything, even into even is going to be even. Similarly, odd number raised to, the moment I talk about raised to, it's going to be odd into odd into odd into odd, any number of times. So any number, right? So any number is going to be an odd number. Of these relations, so don't spend too much time memorizing it. Another thing that quite a lot of students do is take 2 as a representative of an even number and take 1 as a representative of odd number, put those values and check it. That is also doable, but I still don't think you really need to use such tricks in such a silly matter, right? So just use the way we learned it logically, and let's solve a question. Before the question, why did we not do division? What if I divide two even numbers or I divide two odd numbers? We cannot generalize anything because dividing two even numbers may not even result in a integer. For example, 2 by 4 is half. Now there's no concept of half being even or odd. They can best be defined only for integers, right? Remember, even similarly 3 by 2 or 3 by 5, yeah, so there are most of the cases they would not be an integer.